Hello students, again a very warm welcome to MRS math class. Whatever the lectures I have given up to today, that was related to your first order and first degree differential equations. Okay students, but in this lecture I am going to discuss about your first order but the degree is higher. Okay, that means more than 1. Okay, so let us recall first what is order and degree. Already I have said, but for your convenience, that is, if you are the differential equation involving dy by dx, that means first order. Okay, if the equations involving d2y by dx2, that means it is of second order. Okay students, but we are not going to discuss about second order. Okay, we are going to discuss about first order. That means these two will not be there. Okay, but of higher degree. That means it may involve 2, 3 and so on. Okay students, so this is about the order and degree of differential equations. Let us write the general form of first order and a higher degree differential equation. Okay, that is your f of x comma y comma t, okay, nearly equal to your p of n, okay, plus capital P1 of x comma y, okay, then small p to the power n minus 1 plus capital P2 of x comma y into small p to the power n minus 2, okay, up to your p of n minus 1 of x comma y, okay, into small p plus pn of x comma y equal to 0. Okay, you can take this as equation number 1. So what is p? This small p represents here, that is dy by dx. Okay, okay, so now this is a first order higher degree differential equations. Okay, so there is no particular method to solve first order and higher degree differential equations. So we are categorized into different types of equations. Okay, so that may be first one I will discuss today, that is equations solvable for p. Okay, this p divided by dx, then equation solvable for y, then equation solvable for x, then if one variable is missing, okay, then how we can solve. So these things I will discuss in the coming lecture. Okay, but in this lecture I will discuss about the first one, that is your equations solvable for p. Okay, this one I will discuss today. So when we can say that equations is solvable for p, if this equation 1 can be written as p minus alpha 1, okay, into p minus alpha 2, okay, into p minus alpha n. That means the factors of p, okay, in each factor p will be there. If we are able to write in this way, then how we will solve? Okay, so what is the, if we will solve this one, okay, p minus alpha 1, okay, what is p here? P represents dy by dx. That means this is a first order first degree differential equation. Okay, and the solution of first order first degree differential equation already I have discussed. Okay, if you have forgot or you have not seen, please go to my previous lecture, then you can understand how to solve this type of differential equations. Okay, so if you will solve this p minus alpha 1, then we will get the solution in the form of f1 of x comma y of c1 equal to 0. Okay, this is the solution for p minus alpha 1. Similarly, if you will solve p minus alpha 2, then you will get f2 of x comma y comma c2 equal to 0, right? Similarly, if you will solve p minus alpha 1, you will get some fn of x y cn equal to 0, correct? So now what is this c1, c2 and cn? These are the integration constants, right? So if we are taking c1 equal to c2 equal to c3, you can say equal to cn equal to some constant c, then there will be no loss of generality. Okay, so we can write this as f1 of x comma y comma c equal to 0, f of x comma y comma c equal to 0, right? And similarly fn of x comma y comma c equal to 0, right? So now this is the solution for each factor, right? Now if you will combine together, what you will get? That is f1 of x comma y comma c into f2 of x comma y comma c, right? And so on up to fn of x comma y comma c equal to 0. So this is the solution for the differential equation 1 if it can be written as the factors of p. Okay students, I hope up to this there is no doubt. Okay, now we will demonstrate this method by taking examples. Okay, so students, here I have taken a very simple example to demonstrate the solution which is solvable for p. Okay, so here this is the given differential equation. Okay, this one we can factorize in terms of p. Let us see, that is p square minus you can write this is minus 3p minus 2p plus 6 equal to 0, right? So if you take common p here, then you will get p minus 3, right? Then minus 2, if you are taking common, then p minus 3 equal to 0, right? So this will be your p minus 3 into p minus 2 equal to 0. So this differential equation we just factorized by p. Okay, so each term is containing p. Now we will solve each term, right? That means p minus 3, if we are taking 0, then what p represents, that is dy by dx. Okay, so minus 3 equal to 0, correct? Now dy minus 3 dx is 0, right? So now we will do integration, then what we will get, that is y minus 3x, right, equal to c. Okay, this is the solution for this factor. Then another factor if you will take, that is p minus 2 equal to 0, right? Then we will represent p as dy by dx minus 2 equal to 0. Then here dy minus 2 dx equal to 0, right? Which implies by integrating we will get y minus 2x equal to c, right? Now these two solutions will combine together to get the solution for this differential equation, right? That means what you will get, if you combine together, you will get y minus 3x minus c, right, into y minus 2x minus c, right, equal to 0. So this is a very small example I have taken, and I got the solution by separating p, right? Hope you understood. Now another example I will take. Okay, so example number 2. Okay, what is this? This is your PQ, okay, into x plus 2y, okay, plus 3p square x plus y plus y plus 2x into p equal to 0. Okay, so this is another example. Okay, we will solve in this way. Okay, let us factorize this p. What you will get? So first term, first we can take common from each term, right? P we can take common, right? Then what we will get? Here p square, right? Okay, into x plus 2y, right? Plus 3p, right? X plus y, right? Plus y plus 2x equal to 0, right? So what I did in the first step, I have taken p common from each term. Okay, now come to second line. Okay, now this p has taken common, right? So now we will factorize this term, okay, in the form of p, right? So what you will get? P square x plus 2y, right, plus p into, you can write this 3x plus 3y, right? So you can write x plus 2y, right? X plus 2y, okay, plus y plus 2x, right? Just distributed as x plus 2y, y plus 2x. That means this x plus 2x is our 3x, correct? And this 2y plus y is our 3y. Just I distributed to factorize, okay? Plus this term, right? Y plus 2x, correct? Which is equal to 0, right? Now what we will do, that is p is there, okay? Now from this term and this term, okay, so p into x plus 2y, if you are taking common, what will remain here? Only p, right? And here only 1 will be there, okay? Now from this p is multiplied here, right? So this term and this term, what we can take common? Y plus 2x, right? So plus y plus 2x. If you are taking common, then what you will get here? Only p, right? Here only 1, okay, which is equal to 0. Now p is there, okay? From this term and this term, what we can take common? P plus 1 is there in both the terms, right? So you can take common p plus 1, right? Then what we will get? So here only y plus 2x, right? Equal to 0, right? Now what we will do, that is p equal to 0 we can take, right? And p plus 1 is 0, right? And this term equal to 0, right? That is p into x plus 2y plus y plus 2x equal to 0, right? So if this term will be 0, then what we will get? That is dy by dx equal to 0, okay? So dy equal to 0, right? Then after integration, what we will get? Y minus c equal to 0, okay? Clear? Now we will solve this p plus 1 equal to 0. Then what you will get? That is dy by dx plus 1 equal to 0, right? Then dy plus dx equal to 0, right? Now if you will do integration, that I will get y plus x, right, minus c equal to 0, okay? Now we will solve this one. Okay, let us come to this side. Hope this side is over. I can erase now. Okay. Now this term we will take 0, that is p into x plus 2y plus y plus 2x equal to 0, right? So it is p, that is dy, right, into x plus 2y, right, plus y plus 2x into dx equal to 0, right? So this dx I multiplied here, right? I just changed p as dy by dx. Okay, so now we can integrate this one, but before that, this one we can write derivative of, okay, xy plus y square plus x square equal to 0, because this is the exact differential equation. Okay, so you can write this one as derivative of this. Okay, now it will be easier to integrate this one, right? So what you will get while doing integration, you will get xy, okay, plus y square plus x square minus c equal to 0. Okay, students, now we got the solution of each term, right? Now we can combine together to get the solution of this differential equation, right? So after combining, what you will get? Y minus c, right, into y plus x minus c, right, into this one xy plus y square plus x square minus c equal to 0, right? So this is the solution for this cubic differential equation, right? So here I explained these equations which are solvable for p. Okay, so you can solve more problems, okay, by the similar method. Okay, still if you have any doubt or any discussions or any suggestions, please do comment in the comment box.